Geometry was born in Egypt thousands of years ago. Egyptians had to develop a way to accurately remeasure their farming land every year after the Nile flooded. Great Greek mathematicians like Pythagoras and Euclid also spent a great deal of time studying the geometric properties of triangles, and today you could find a triangular shape in almost every structure you see around you. So what is it about triangles that have fascinated mankind throughout history? Hi, my name is Amashni. In this series of lessons in geometry, we are going to try to find out what it is that makes triangles so special. By the end of this lesson, you should be able to describe the relationship between the sides of a triangle, describe the relationship between the angles of a triangle and the sides of a triangle. Before continuing with our investigation of triangles, there is an important issue that we first have to consider. Can you think of triangular shapes that you find around you? Now, I'm sure you have seen many of these before, but also have a careful look at the shapes in this logo. And look at the roof construction on these parking spaces. Do you notice anything strange? Although all of these shapes are triangular shapes, they all occur on different surfaces. Let's have a look at them again. The road signs are good examples of triangular shapes on a flat surface. But in this logo, the triangular shape occurs on a surface that is dented outward. And in this example, the triangular shapes formed by the shade netting occur on a surface that is dented inwards. It is very important for you to remember that in our investigation of triangles, we will be examining triangles that occur on flat surfaces and not triangles that occur on curved surfaces. Now, let's kick off our investigation by an activity called a thinking experiment. To do this thinking experiment, we need to first make a conjecture. Don't worry, this sounds a lot more complicated than it is. A conjecture is a statement, an opinion, or a conclusion based on guesswork. Well, this simply means that a conjecture is not a fact. It is something that we think and not something that we know. So how do we make a conjecture about triangles? To do this, let's ask ourselves a couple of questions. If you look at these triangles, what is the first thing that you notice? For me, the most obvious thing about a triangle is that it always has three sides. Now ask yourself, could the sides of a triangle be of any length? Now I think this is a good question, so let's make this the starting point of our thinking experiment. For the purposes of our lesson, we can voice the opinion or make the conjecture that we think that any three combinations of line segments linked together on a flat surface would form a triangle. Now, of course, we need to test whether this is true or not. I have asked 4 learners to help me with this experiment. I gave each of the learners a bundle of sticks and asked them to form a triangle. Now, this seems easy enough, but let's see what happened. Here's our conjecture, that we think that any 3 combinations of line segments linked together on a flat surface would form a triangle. I have asked Claudio, who's got the red bunch of sticks, Miguel with the yellow, Wesley with the blue, and Jonathan with the green to construct a triangle. Try and construct your triangle using the sticks. All right, maybe it's not going to work. All right, let's, using our pens, mark off the points on the page wherever you are at, whether you constructed the triangle or not. What we're going to try and do is measure the lengths and try to find some kind of relationship. Okay, so use a pen, mark off the lengths, of the sides that you've got, measure them, and write the measurements in. We know that Claudio and Wesley have drawn the triangle, and Jonathan and Miguel did not succeed in making the triangle. Let's try to find out why. Is there a relationship?
Add your two shorter sides.
Yeah, my two short sides, I get 22.
I get 22.
So what have you discussed, Claudio?
Well, we discussed on ours that my two sides of my triangle are higher than my base of my triangle, and on his triangle that wasn't formed that very well because of the two shorter sides, which are, if they are measured, they are smaller in length in measurement than the base.
Okay, so which is the base?
The base is your longer side.
If the sum of the two shorter sides are smaller than the long side, then it does not make a triangle.
If the sum of the shortest sides is smaller than the longest side, it does not make a triangle.
Yes.
Jonathan, is this true for your triangle?
Yes, because my two shorter sides are not higher than the base.
What is the sum of your shorter sides?
22.
22. So you're saying 22 centimeters is less than 24, and therefore yours didn't make a triangle. Well, can you see that by proving our initial thinking or conjecture was not quite correct, we have discovered a relationship between the sides of a triangle? Let's formulate this relationship in a mathematical way. A triangle can only be formed if the sum of the two shorter sides is longer than the length of the longer side. Or in other words, AB plus BC must be greater than AC. For group 1, the sum of the shorter sides is 22. This is greater than or longer than 16, which is the length of the longer side. That is why group 1 formed a triangle. In group 2, BC plus AC is equal to 22, but this is shorter than 24, which is the length of AB, the longer side. Therefore, group 2 did not form a triangle. You should see the same pattern in the inequalities for group 3 and group 4. The sum of the shorter sides cannot be equal to or less than the length of the longer side. Now, can you believe it? Through this fun experiment, we have already achieved our first outcome. We have formulated a relationship between the sides of a triangle. Let's investigate whether a relationship exists between the angles of a triangle and the sides of a triangle. For this activity, we will go back to our learners. We will look at the groups of sticks where the triangles were constructed. Right, now write down the lengths and measure the angles. So we've measured the angles. What have you noticed? Is there a relationship between the lengths of the sides and the angles? In your diagram, find the longest side.
GF.
GF is your longest side, and there?
And C.
AC. What can you tell me about the angle opposite the longest side?
GF is opposite to E. 89.
So in your diagram, which is your opposite angle?
GF, and the opposite angle is E.
So angle E is opposite to GF, which is the longest side. What do you tell me? What can you tell me about
It's
its
the
measurement?
largest angle.
It's the largest angle.
Yeah.
You guys?
Same, yeah.
Same.
Okay, so you're saying the largest angle
Is opposite the largest length.
is opposite the largest length.
Yes.
Yes.
What about the other sides?
The smallest angle is opposite the smallest side.
Smallest angle is opposite the smallest side. Is this true for you as well?
Our medium side, well, not the smallest and not the biggest,
Yeah.
is the same as the angle A, which is not our biggest and it's not our smallest.
So you're saying the middle.
Yeah, the middle one.
Yeah.
The middle angle is 50 and it's opposite the middle side. Is there a conclusion?
Yes.
The largest length is opposite the largest angle.
Very
It's
good.
the
Do you
same-
think that's the
same
best
for
way of...
that they're all in proportion.
What does that mean?
Which means that the longest is opposite the longest, the shortest is opposite the shortest, and the medium is opposite the medium.
Okay, so we're saying that the largest angle is opposite the longest side, and the smallest angle is opposite the smallest side, and the middle angle is opposite the middle side.
Yes.
Well, it seems that we have discovered yet another relationship, and we have achieved our second outcome. Let's have a look at our tables. It is quite clear from this information that the largest angle is situated opposite the longest side. The angle opposite the middle side lies between the largest and smallest angle in size. And the angle opposite the shortest side is the smallest. These two relationships that we have discovered in today's lesson are extremely important. They are true for all triangles, and you should definitely keep them in mind when you analyze triangles in the future. Let's recap what we have learned today. We have learned that a fixed relationship exists between the sides of a triangle. The sum of the two shortest sides must always be longer than the length of the longest side. We also found a fixed relationship between the angles and sides of a triangle. The angle opposite the longest side is the largest. The angle opposite the middle side lies between the largest and the smallest angle. And the angle opposite the shortest side is the smallest. Thank you for joining me in today's lesson. I look forward to seeing you in lesson 2, where we look at how triangles are named. See you then.